Welcome back to linear algebra. Let's jump a donkey. Here we go. What is a linear combination of matrices? It's basically an expression in which it's a structured C1A1 plus C2A2 plus dot 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 plus CRAR, in which C1 through CN, 3CR, C1 through CN or CR, whatever the variable is, it's irrelevant. These are scalars and the A's are matrices, and they're matrices of the same size. What is the size of the augmented matrix of a linear system of m equations and n unknowns? The size of the augmented matrix of a linear system. Size of the augmented matrix. M equations. So it's going to have m rows, n unknowns, n plus 1 columns. What is required for two matrices to be equal? They need to be the same size, and all the corresponding entries must be equal as well. Okay, if A equals A sub ij, what does A sub 22 denote? Denotes A 22. A sub 22, yeah. If A is an invertible matrix and K does not equal 0, how might you write K, the product of K times A, or the inverse of the product of K times A? It's a multiple of the inverse of A. The inverse of K times the inverse of A. Of what matrix is A to the power negative n, the inverse? It's the inverse of A to the n, right? Yeah, all right. That's it for Anki. So yesterday we finished up the 1.7 on triangular, diagonal, and symmetrical matrices. Symmetrical matrices. This is a matrix in which transpose equals the original matrix. And how do you identify a symmetrical matrix? By just looking at it. Well, first, I got the definition wrong. It's a symmetrical matrix. It's a square matrix in which, like I said, the transpose equals the original. You can tell if it is a you can tell if it's a symmetric matrix by looking at it. It's got to be a square, first of all. If it's a square matrix, then basically the entries that are mirrored over the main diagonal must be equal. The main diagonal doesn't matter because when you transpose it, the main diagonal stays the same as the main diagonal before. So we've probably gotten to some properties then about symmetrical matrices. Probably. What would those properties have to do with? Inverse. So a symmetrical matrix is not necessarily invertible. But if it is, what? If it is, I don't know. Man, there's a lot that I'm forgetting now. Okay, here we go. Here's something. A matrix times its transpose always equals a square matrix, and that matrix is a symmetric matrix. I think maybe if the transpose is invertible. Wait, no, it doesn't matter about the transpose being invertible. I'm forgetting now. if A is invertible, then A times the transpose is invertible, as well as the transpose times A is invertible. We know that, okay. Oh, interesting, okay. Right, if they are invertible, if the symmetrical inverse is invertible, then the inverse is also symmetric. I think that's what it was. I think I just wrote that wrong. It is also symmetric. Symmetric, not symmetrical. Symmetric. All right, there we go. Okay. If A is symmetric, so is A to the power K, so is the transpose of A. If A and B are symmetric, then A plus B is symmetric and B plus A is symmetric. Or no, A plus B is symmetric. Of course, then B plus A would also be symmetric because this, commutative. And because A and B are unknown, they're general. If A and B are also symmetric, then A minus B is symmetric. A times B is not necessarily symmetric, but it is if and only if A and B commute. Okay, now we're caught up. I'm going to start working on the problems in 1.7, and we're going to go from there and talk to you in a bit. All right, guys. I think something's working because I just ripped through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different problems. Let's see if I can try to recall what happens. The first one, we were just looking at a matrix saying, is it upper triangular, is it lower triangular, is it diagonal? Is it invertible? Is it just by inspection, is it invertible? This question was what? I think multiplying by a diagonal matrix just by inspection. This was given a matrix just by inspection. What is the square of the matrix? What is the to the power of -2? What is the power of -k? I think this was multiplying by a diagonal again, diagonal matrix. This was a diagonal matrix to a power. This was multiplying by a diagonal matrix when it's variables rather than numbers. This was find a value for this. This was x. Find the value for to make this symmetrical, so x equals -1. Determine if its matrix is invertible by inspection. I have a question to check tomorrow. Main diagonal has to be non-zero for a triangular matrix to be invertible, I'm pretty sure, but we'll check on that. Here is find the resulting entries of a main diagonal of multiplication of either two upper triangular matrices or two lower triangular matrices. I believe you just multiply the corresponding entries of the main diagonal together. This was find all values of A for which the matrix is symmetric, I believe. This is find all values of X for which the triangular matrix is invertible, or the diagonal, triangular matrix is invertible. So I wrote it in this form. I can't remember what that form's called. I learned that in pre-calc. But yeah, all real numbers essentially, except for can't be equal to 1, -2, or 4. So what can you say if you've got a upper triangular matrix or a lower triangular matrix that you're taking the inverse of? What can you say about the main diagonal? I believe you can say that the entries of the main diagonal will be equal to the reciprocal in the original matrix. So, all right, that was just a massive shred through. We'll be back for more practice problems tomorrow. So talk to you then. See you.